Okay, our next sections are about arc length and sector area, and then our unit conversion with linear and angular velocity, right? Something that a lot of you struggled with was the unit conversion. So we're going to find arc length and area of the shaded sector here, right? So we have a circle, we have a radius, we need to know the radius, which I think we're going to be given, and we need to know the central angle in order to find these things out. Okay, so let's see, what do we know? We know that the radius is 6, check, and a central angle of 145. So we have enough information. Now, when we have an angle in degrees, we have to use the degree formula. S over 2 pi r, right? It's a circumference. The arc length is compared to the circumference, just like the angle degree is compared to 360 degrees. Okay, when we have a degree as an angle, we use the degree proportion in order to find this length. So we know what our radius is, that's 6. We know what our angle is, that's 145 degrees. So this is just a matter of cross multiplying. We're going to take our 2 pi 6, which is the same as 12 pi, and we're going to multiply it by 145, and then we're going to divide by 360. Okay, so we do all of this times 145, and we divide by 360. And when we do that in our calculator, we get 15.184 centimeters as the length of this arc. Okay, so and degree angle needs a degree proportion. Same thing with area. Area over pi r squared, that's the area formula for a circle, is equal to the degree of the angle over 360. Okay, so once again, we know what our radius is. Our radius is 6. So we're going to do pi 6 squared. We know what our angle is. That's 145. So we're going to cross multiply. Pi 6 squared, which is 36 pi. Right, we're going to multiply that by 145, and then we're going to divide by 360. All in the calculator. Okay, and when we do that, we get an area of 45.553 square centimeters. So make sure that you can do this multiplication in your calculator. Okay, and then divide by 360. So those are the formulas that you need if you have an angle in degrees, right? It's different if we have a radian, if it's pi over something, but this doesn't say that. This says a degree, so we have to use the degree formula. Okay, linear and angular velocity and unit conversion, right? This is not something that your chat shows you how to do. So the radius of our tire is 2.5 feet. That's good to know. The tire is rotating. So rotating, this is your omega. This is your angular velocity at 300 revolutions per minute. That's 300 RPMs. What is the speed of the bus in miles per hour? So here's our unit conversion. We want to convert to miles per hour. So we have the formula velocity or linear velocity, linear speed equals angular speed times the radius. So we know that omega was 300 revolutions every minute. So the rev goes on top, and then we make a division line and put minutes on bottom. Revolutions per means divide, so revolutions over minutes. Times our radius of 2.5 feet per radian angle on your circle. So this is how we do the radius. Always feet or units per radian, because we need to have a fraction for everything. Now let's do our conversion. We have minutes, we want hours. That's a pretty, hopefully you know this one. There are 60 minutes in 1 hour. That will cancel out our minute units. Okay, we want miles, and we have feet. So the miles to feet, there are 5,280 feet in 1 mile. Okay, if feet are on top, then the feet units have to go on bottom so they can cancel out. And then the last thing I have here is this revolutions and radians, right? I have to get rid of both of these angular distances or angular values. So I know that 2 pi radians one way all the way around the circle is equal to 1 revolution. Okay, and that will get rid of my radians and my revs with one fraction, with one comparison, one conversion. Okay, that looks like I have everything, right? I have miles on top and I have hours on bottom. So now we multiply 300 times 2.5 times 60 times 2 pi. Okay, and we get something like 282,000. And then we come back and we divide that by 5,280. Okay, and if you do this nicely in your calculator, you should get a speed of 53.45 miles per hour. Okay, it's all this unit conversion, right? Show me all the units, all the conversions, all the units while we're doing it, unit per unit per unit. What are their equivalents? Right, 60 minutes is equivalent to 1 hour. Okay, our last one, a bus is traveling at a rate of 25 kilometers per hour. Oh, kilometers, I see. So that's our V is equal to 25 kmph. The front tire has a diameter of 3 feet. Diameter, which means it has a radius of 1.5 feet, right? We always want radius when we're doing these things. And it looks like we're being asked for angular velocity, which is your omega. Okay, so here's your formula. We're using that same formula. V is equal to omega times r. But we're solving it now for omega, so we have to divide both sides by the radius. So your angular velocity is equal to the linear divided by the radius. Okay, so let's put that in. We know our velocity is 25 kilometers every hour, so we make that as a fraction. Every 1 hour. And now we're dividing by the radius, so that means that the 1.5 feet will go in the denominator as a division, and we're going to put rad on top. Okay, so now comes the conversion part. Let's do hours to minutes because that one's usually pretty simple. I know that there are 60 minutes in 1 hour. Nope, that's not what I want. We need to switch that around, don't we? Hours on the bottom here, which means 1 hour needs to go in your numerator, and 60 minutes goes in the bottom. That way hours can cancel with hours. There we go, that's better. And now let's go to, what's our next one? Oh my goodness, we have kilometers in feet. Okay, I'm gonna look this up. It tells me that there are 3,000, I'm telling you, the internet. The internet tells me there are 3,280.84 feet in every 1 kilometer. Okay, so don't worry. You'll be either given that or it won't be a foot to kilometer thing. Okay, so there's your ratio of kilometers to feet, right? Because we want revolutions per minute. It doesn't have any distance in there. And then our last one that we need to do is get rid of this radians and change it to revolutions. So we want 1 revolution equals 2 pi radians. So then we can cancel out our radians, and we have revolutions on top, and we have minutes per on the bottom, which is exactly what we want. Okay, so let's put all this in the calculator. 25 times 3,280.84 divided by 1.5 times 60 times 2 pi. And when we do that in the calculator, I get an angular velocity of 145.05 revolutions per minute. Okay, so when you're doing your unit conversions, right, you want to think about their equivalents. How many hours are there in minutes and how many miles are there in feet? Switch all those, but how does it convert? Okay, so that's how we do our unit conversion with linear and angular velocity.